Okay, let's take this to the real world. We said in the last clip that the elasticity of demand, and now remember we're doing this in absolute value terms, the elasticity in the linear model is B times P over Q. And from that, we derived an expression for B as a function of the elasticity and quantity and price. Now, if B is equal to the elasticity times quantity over price in general, then in particular, it's going to be equal to your elasticity estimate from the real world times the specific price-quantity ratio that you've observed in your study of the pre-intervention policy situation that you're looking at. So now we can take these real-world numbers that we've gotten from our research and use them to compute the B parameter in order to do our analysis. What about a situation where you have two known values of price and quantity, but you don't have an estimate of elasticity from some existing literature? We can still make headway in this situation so long as we're confident that our two measures or observations of price and quantity really belong on the same demand curve. I'll explain what I mean by that at the end of this series of lecture clips when I talk about when you can trust an estimate of elasticity. This is the case where, in effect, you're estimating elasticity, or at least the slope of the demand curve, yourself from some price and quantity observations. So what can we do? Well, let's suppose that we have two observations. We'll call one of them P0, Q0, and the other one will be P1 and Q1, giving us 2 points, which, if we're assuming a linear demand curve, must in fact be on the same straight line. What we're trying to do is to come up with some estimate of the slope of that, -1 over b, and if we can get that, then we can extract this b parameter from it, which is what we're looking for. Well, we know that slope, in this case -1 over b, slope is the rise over run, right? That's sort of the definition of the slope of a line. Now, the rise in this case is P1 minus P0. It's how much the price has gone up. Okay? And the run is Q0 minus Q1, or if you want, Q1 minus Q0 to get the run going in the right direction. So what do we have? The rise over run is P1 minus P0 over Q1 minus Q0. Now, if -1 over b is this expression, then we can just multiply it by -1 and take its reciprocal, and what we get is that b is equal to Q0 minus Q1 divided by P1 minus P0. And we have our expression for the b parameter in the linear model as a function of our real-world observations of quantity and price.